Question number 5, I've got 1 minus 2 sine of pi x, that's the graph. So a curved bracket, so an open circle. Okay, let g of x equal this. Same rule as that. Sketch the graph of g on the axis provided. Choose a different color. I'm going to complete and we should have a graph. Make sure you get a nice curve happening. And make sure you color in those dots. So this is g of x, where that is f of x. Sketch the graph on the axis and the axis provided, beautiful. Find the solution, so find the x-intercepts. So I'm going to have 1 minus 2 sine of pi x equaling 0. So negative 2 sine of pi x equaling negative 1. So the sine of pi x equals a half. All stations to Coolaroo, sine is positive in the first and the second. And in the first it's pi on 6. Therefore pi x equals pi on 6 or 5 pi on 6, which means x equals 1/6 or 5/6. They're my two answers. And I'm now going to label this 1/6 and 5/6 so that my graph is fully labelled with the y-intercept and x-intercepts labelled. And my endpoints are labelled at -1, 1 and 2 and 1. Beautiful. And find the area bound by the graph of g and the x-axis. Bound by the graph of g and the x-axis is only this bit, because this bit here is bound by g, f and the x-axis, and it's only by g and the x-axis. So the area is going to equal a negative area, so the area equals negative 1/6 to 5/6 of 1 minus 2 sine of pi x dx. So I've got my one method marked by writing the area, making sure that my area was a positive answer by putting a negative there. So it is, I'm going to turn that into 5/6 down here and 1/6 up there, and then turn it into positive. So the integral of 1 is x. The integral of sine is negative cos, so plus 2 cos of pi x, and my a value is pi, so I need to divide by pi from 1/6 back to 5/6. So I'm going to have 1/6 plus 2 on pi cos of pi on 6 minus 5/6 minus 2 on pi cos of 5 pi on 6. Root 3 on pi minus 2/3 square units.